An inclinometer is a device for measuring angles of inclination, height, or dip of the rock bed relative to the ground level. In the simplest case, this tool consists of a magnetic needle on an axis needle, vertical circle whose center coincides with the axis of the needle, a pendulum, and a full horizontal circle located at the base of the tripod. The limb is divided into 360 degrees in a counterclockwise direction. East and west have swapped places. In order to determine the tip angle of the inclinometer is placed edgewise on the rock bed surface, perpendicular to the bedding planes of rock, so that the letter C will be turned into the dip line direction, and the pendulum will show the largest angle on the limb, which is the dip angle. The line drawn on the rock surface along the edge of the inclinometer will be the dip line. The line perpendicular to the dip line will show the bed course. Inclinometers are divided into two groups, for direct measurements and indirect measurements. In addition to magnetic and mechanical inclinometers for registration, electrometric, chemical, and recently electronic inclinometers are used. Inclinometers are used in the mining industry to determine the angle and compass direction of deviation of the borehole, therefore controlling its spatial position. In the cranes, inclinometers are used to control the operational and residual deflection of the boom, as well as to control the inclination angle of the crane in general. The load on the boom can be measured indirectly, based on the readings of several inclinometers. Monitoring of safe inclination angles of cranes and earth-moving equipment, in particular large ones. Monitoring the status of bridge supports and pipelines, tracking the status of architectural structures, direct measurement of inclination angles of highways from a moving vehicle, monitoring the inclination angle of a car body in anti-theft systems. Therefore, despite the apparent simplicity, it is still a very useful instrument.